Continuing on our exploration of compound statements and the introduction of the tools that really makes programming powerful, we're going to examine in more detail while and for loops in Python. And in order to do that, we're going to install a package, IPython blocks, that will help us visualize what's going on with these loops to a degree, but I also wanted to provide a link to Software Carpentry, which has a lot of nice lessons on learning Python, to their lesson on control flow. Okay, so first off, let's install IPython blocks. And we can just do this with pip. And so this is a system command. So within a Python notebook code cell, do an exclamation point pip install IPython blocks. In my case, this is already installed, so I'll get this message that I could upgrade it. You should get a full install message. Okay, now let's explore using IPython blocks. So the first thing we do is we make a block grid. So a block grid consists of an array of blocks, and each block has a size, height, and width, and a color, which is an RGB tuple, and each red, green, blue value is encoded from 0 to 255. So let's import our block grid. And now let's create one. So in this case, I'm defining a grid. So it's 10 by 10 blocks, and each color is going to be filled with a red value of 250, a green value of 218, and a blue value of 94, which I have found a website that lets you look up colors. And so this is Naples yellow, which was one of my favorite colors when I was painting in high school. So here is the resulting grid generated from that statement. Okay, so the first loop structure that we're going to go over in this lecture are for loops. So for loops iterate over sequences. Lists, tuples, strings, have strings there twice. You have sets, I believe, dictionaries, and iterators. So generally any iterable object. So we'll learn when we talk about classes what makes an object iterable, but at this stage we can just think of the basic collections that we've worked with. So if we loop over a dictionary, so dictionaries are kind of more complex in the sense that they're not, you have these key value pairs, but they're not ordered. So looping over dictionaries is equivalent to looping over the keys of the dictionary. So here I define a dictionary of a complete blood count. And if I do this for loop, we're going to see one behavior. And then if I get the items, we'll get another behavior. But before we do that, let's just go over the structure. So much like the if statement, we have a keyword for, and then we're going to have a colon here, which is going to mark the beginning of a block of code. And then we have an indented block of code, in this case a single line, which is print value. So this is our for loop. So the uniqueness of the structure of the for value is we provide some sequence, some iterable object that we're going to iterate over, in this case the complete blood count dictionary. And then we define a variable value for value in CBC. So this is going to take every whatever it views as an item. Item is going to be a bad word because of the specific meaning of items in dictionaries. But for each piece in CBC, we're going to call it value. And what we're going to do is in this loop is we're going to print that value. In this case, I'm doing it a little different. Instead of just iterating directly over the dictionary, which, as I said in the last slide, means iterating over the keys, in this case we're going to call the items method of dictionary, which returns a list of key values stored in tuples, and then print those. Here we're doing the same thing, but this is called tuple unpacking, And so instead of returning it into a single tuple, the values in the tuple are going to be stored into these separate variables, test and value. So let's just see what this looks like. So in this case, when we're looping over the dictionary, we're looping over the keys. So you can see that we have white blood count, red blood count, hemoglobin, hematocrit, and lymphocytes, and not in those orders. Each one of those is getting pulled out of CBC, assigned to value, printed, and then we repeat, get the next value, which in this case was hemoglobin, printed, and so on. If we look at the next output, now we're returning these tuple pairs. So here we're printing lymphocytes with the value so this is the key value pair, lymphocytes 32, hemoglobin 15.9, so forth. And here this looks very similar. You can just see how test and value have been assigned to the two variables, and then we're printing them out in a more elegant way. So here we are, we're going to iterate over a set. So we provide the set of 1, 2, 3, 3, 3, 4, and as we print over each element, we should get 1, 2, 3, 4, because as the set's defined, even though we type it in here with these multiple threes, the set only contains unique values, so only 1 3 is kept. And we have that output. Okay, here I define a sequence that is a string. And again, the syntax is the same. I have my keyword for, a variable which I'm calling B, which is what we're going to assign each piece of sequence to as it iterates through it. So for B in sequence, I'm going to print B followed by a space. And this dangling comma here simply means that print doesn't automatically add on a new line character. So here you see we've got the individual pieces of this sequence, T, G, C, getting pulled out, assigned to B, printed, followed by printing a space, and then we pull off the next one, pull it out, print it, and so on. Okay, so now let's do this with our block grid. So if you recall, we have our grid, which is a 10 by 10 grid of Maple Yellow's blocks, and we're going to iterate over each block in the grid. And these blocks have a row and a column attribute, which are going to be X and Y. And we're going to, within our for statement, have a block, an if statement, where if the row and column are both even, divisible by 2, then we're going to color that block with a new color. Okay, so here's the resulting output. I think that's Prussian blue, if I remember what I selected. So we're going over each block, and I don't know the order that it's pulling things out, but we do a test. So for block in grid, if the block row is has a modulus 2 is equal to this block dot column modulus 2, then we color it in with this different color. Okay, so we can play around with this a little more, and I've got here, if we look at my source code, I've got commented out a link to Wilms tumor JPEG, just because it kind of lacked structure, so it was hard to really appreciate what we were working with. And then I have active a source to a William Turner painting. Turner is my favorite painter, and this is a painting that I had copied in high school, so giving myself some personal fun here. So what we're going to do is we're going to analyze this image using the grid block structure and look at for loops, etc. So first, let's import some libraries. So we're going to, this is a library for reading in images and manipulating them. These are libraries for, this one is grabbing resources from the web. This will be coupled with that so that the web address will look like a file. And itertools are something I'm not really familiar with, but they're kind of utilities that will help us in different iteration tasks. Okay, so we're going to grab the Turner image and resize it to something smaller, which I'm showing here. So I provide the URL for the Turner image. If you want to work with the Wilms tumor, you can just switch which line is commented out. We create a file-like object using the URL location and this C-string IO. And then normally what image is doing is it opens images from files. So this is just creating something that looks like a file, although it's actually a remote web resource. So we read it in. It has attributes like size, etc. Okay, we're going to define the block size we're going to use on our new grid. And we're going to, the original image is kind of large, so we're going to downsample it using the resize method to something that will be a little more manageable on our notebook. So let me just make sure that runs okay. Okay, we're now ready to define block grids. Okay, so we grab the image data and we're going to fill in the block grid with the images. And so here I'm just doing some checking to make sure that my image data size and my grid shape are similar. Which I guess I can. So this is just demonstrating that we've matched up. And so our block grid should look like our image. If you're interested in looking up the documentation for some of these things, it's all on the Python website except for PIL, which is a third-party package. Okay. So here we're taking our grid and our image data. We're zipping them together so that we're iterating over each piece of the image and each piece of the grid at the same time. And we're going to assign the RGB values of the grid block that we've pulled out to the corresponding colors in the image location. Okay. We can toggle grid lines on and off. And so here is what the grid image looks like. If we turn the lines back on, see, that's what we have there. Okay, so now we're going to iterate over each block in the grid and we're going to ask a question. We're going to ask if the blue value in that block is less than 100. And if it is, we're going to change the RGB color. We're basically just going to invert the color by taking 255 and subtracting the red, green, blue values at each location. And then let's redraw it. Okay, so this is where everywhere we have blue less than 100, we've now inverted the colors in the image. Okay, there's a number of useful tools that you'll end up using in particularly for loops, and those are the range function and the xrange function. So range creates a list of numbers, and you can specify an optional beginning, value, a required end value, and then a step size. Xrange behaves just like range, except for it creates an iterator. So that is, you're not actually creating the entire list at once, which if you have a very large array, that can become a problem with how much time and you're allocating the memory and the actual memory that you're grabbing for your computer. So here I've defined just a function that's just going to sum up over a range of numbers, and we do it with either the range function or the x range. Again, range creates a whole list, so as these numbers get large, so in this case, let's see, we've got 100 million elements. How long does it take us to create that list and sum over it compared to if we don't create the list but we create the iterator? If it gets too large, it'll just freeze up. And so let me do a smaller number, and hopefully this won't take too long. So you can see when we're allocating the array, the whole list, it's taking half again as long as if you are just creating the iterator. And if I get brave and add another 0, see if this will get us anywhere. I have actually frozen the computer before by making this number too large, and hopefully that won't be the case here. Well, I'm going to see if I can using the slideshow. My tools are hidden from me, so I don't know if I can stop this without exiting the slideshow. Let's see. Okay, is it still running? Let's come back to where we are here. Still busy. I'm going to stop that. Start up the slideshow again. So you can experiment with that on your own time. Okay, so let's look at while loops now. So while loops are the most general of Python loops. And the way it's structured is that you have the keyword while, some condition that evaluates to true or false, and while it's true, the following block of code is executed. So you can think of it in terms of, while a condition is true, do this. Now these terms for and while are just kind of second nature to me, although I was attending a talk in the summer, and the person was saying that for people that don't come with a programming background, the for and while have much different meanings than what programmers assign to it. So if you're a little confused, just talk with me and we'll try to work through this. So I can make a while loop that functions very similar to a for loop, only in a more verbose manner. So here I'm going to define a grid, fill it with some color. Let's see, what color do we have that I'm saying that we're doing here. Oh, I can't. Scrolling off the side of my screen. So I'm going to I start by initializing a variable I, and then I'm going to ask, while I is less than grid width, begin a block of code. Then I create a new variable j for j equals 0, and I have a nested loop here. So while j is less than the grid height, again, the colon marks the start of a new block of code. And now I'm going to ask a question. So if I modulus 3 equals j modulus 2, then I'm going to color that grid with a new RGB color. And then I'm going to increment my j value within this loop. Once I go all the way through from j up to grid height, then I'm going to increment my I value, test to make sure that I is still less than grid.width, and then we're going to run through it, and then it'll be displayed. Okay, so here's the original grid. think that's phthalo green. And here is the output from my while loop, where I'm coloring it a more reddish color, where the conditions come out equal. And you can play around with different conditions or different increments. You can see here we're skipping all these x values. They're not getting recolored at all because we're incrementing by 2. We can do the same thing with the j increment for the y value, and so on. So this is just a nice little package to help you kind of explore and experiment and work with these different looping conditions and see and visually appreciate what the results are. Okay, so while loops may execute anywhere between 0 and an infinite number of times. So 0, you may define this while loop and the condition never is true. Whereas you can also define a while loop where the condition is always true, and so it never exits it. Infinite loops can be broken out of with a break statement, and this is something that can be very useful, and I'll provide a few demonstrations of that. So I'm asking the user to enter an even number. And what do I do if they don't, if they're not compliant? Well, I want to keep doing it until they enter that. And so here, you see while true. So true is always true. So in principle, this while loop will execute forever. I'm having them enter a number, and then I do a test. So I say if y modulus 2 equals 0, that means it's even. I divide it by 2 and there's no remainder. Then I'm going to break. So break takes me out of the parent loop. And so let's just see how this works. So enter an even number. I just keep entering non-even numbers. It keeps asking me to do the same thing until I enter an even number, and then it prints the value. It exits the loop and prints the value. If I just write off, enter an even number, it's executed once. This condition evaluates as true, and so we break out of the code, the loop. Okay, similarly, enter a non-negative number. So here I begin by initializing my value to -1, and then as long as the num, the variable num, is less than 0, I'm going to keep prompting for the input. So if I do so on. So these loops with a break statement are one way of working with getting input from a user that's compliant with what you're asking them to do. Okay, here he's using a while loop to sum up all the numbers between 1 and 100. So we start by initializing a variable x equal to 1. And then I'm going to ask, so I have the while condition, and these parentheses don't need to be here. So while some condition, in this case x is less than or equal to 100, start a code block by a colon and an indentation level, add to sum the value x, and then increment x. And then we can print sum, and we can see what our final value of x is. So the numbers between 1 and 100 add up to 50/50, and you see that our last value of x is 101, and that's because we add 1 to it. We come up here, we do this test, and we see that 101 is not less than or equal to 100, so this evaluates as false, and so we exit out of the while loop at that point. Okay, so now I have a little exercise. So we're going to use for loops and the counter class from Python to determine letter frequency in a radiology report. So I have the report here. I've broken it into, I've already run a split on it so that the words are now a list. and I create a letters list. So we're looking at frequency of letters in this case. And so I'm going to iterate over every word in the list. So I get for W in words. Now W is a string, so that's a sequence. And so I can iterate over the components of that string, the individual letters. So in here I create another for loop for L in W, create a new block with a colon and an indentation, and I add that letter to the list letters. And then when I've iterated through all the words and all the letters in the words, I have a list of all the letters that were in the report, and I can call counter, and it has a method most common, and I'm telling it to return the 10 most common letters in the report. So to no surprise, E is the most common letter in the report. Of course, we could do this different ways, more concisely. So here we're taking all the words, we're joining them together. So we have a single sequence again, a string again, and we can use the counter that way. All right, and that's it for our for and while loops.